How are you? How are you doing today? You good?
I'm good, and yourself?
I'm good. Thank you for joining in. So we're gonna revise. What time are you writing tomorrow?
At 8:30.
Half eight. Okay. Uh, okay. Just give me a second. So now this is the question paper that we're going to look at. November 2024. So we'll try to answer some of the questions from this one. Okay. And
No
if
problem.
you have a question, please tell me so that I can assist you. Okay. All right. Okay. So on this question paper, I'm going to let's first start with this question two,
Yes.
which has to do with Newton's law. So this is the question that I will first try to attempt. Okay. So they say that a 3 kg block rests on a rough horizontal table, and we are told that it is connected to a 1.5 kg block by a light intensible string and is passing over a frictionless pulley. The 1.5 kg blocks is the one that is hanging vertically as shown in the diagram. So we can see that there's an applied force of 25 newtons on the 3 kg, and it is applied at an angle and also causing the block to accelerate to the left. So the direction of the motion is left. So the coefficient of kinetic friction between the block and the 3 kg is given at 0.1. First question, they want you to state Newton's second law in weights. So since you are writing, this is something that you should already know by now, that when a resultant force, okay, just give me a second. It's saying that when a resultant force say that when a resultant force acts on an object, the object will accelerate in what? Direction, in the direction of uh, net force, And then after this is where you need to continue saying that the acceleration, I won't write it in fulls. The acceleration is directly proportional to that F net, and also the acceleration is inversely proportional to the mass. Do you understand?
Yes, sir.
That's the definition of Newton second law. Okay, so now if I let's continue with the what is this? The second question. It says that they want you to calculate the magnitude of what? The magnitude of kinetic friction acting on block A. Do you understand?
Yes, sir.
So to find that, you need to understand the formula that we need to use to calculate that magnitude. Remember the formula for kinetic friction. To answer this 2.2, the formula goes like this. Fk, it's equals to, we're going to take the coefficient of kinetic friction we're going to multiply this with the normal force, Fn. But now, you need to ask yourself, why is this question 4 marks? Why is the question 4 marks? Because the normal force is just like something that is easy to do. The reason this is 4 marks is because, okay, it's fine. You are given the coefficient of friction. There is a mark for calculating the normal force. And please don't make mistake. We know that this object is in contact with the surface. And now, if it's in contact with the surface, the difference is that the force is applied at an angle. So if it's applied at an angle, we have a vertical component like this, which is Fy, and this, it reduces the weight. Do you understand?
Yes, sir.
So when you draw a free body diagram, you're going to have something like this. Your Fy going up, then you're going to have a normal force also going up. That's your Fn going up. Then you have your weight going down. That's your Fg. So if we say F net is equals to 0, so I'm going to say my F net is equals to 0. I'm going to take up as positive and add all the forces that are going up, subtract all the forces that are going down. This is 0. Therefore, you can see that your normal force is equals to Fg, then you subtract Fy. So that's why we are saying that the normal force, when the force is applied at an angle, there's a vertical component that reduces the weight. So this is Fg minus Fy. That is the formula for normal force. So my normal force will be the mass, that will be mg minus the F applied, the sine of theta. Do you understand that part?
Yes.
That is your normal force. That's why this question is like 4 mark question. So I'll just go to my formula and say my Fk is the coefficient of kinetic friction multiplied by the normal force of mg minus the F applied, the sine of theta, and then Fk, it will be 0, 1 inside the bracket, the mass, that is for the 3 kg block. And then we're going to have this as 9.8. Then you subtract your F applied, it's given as 25. The sine of that angle, which is 15 degrees. Right. We put everything on the calculator correctly. Make sure that when you put this on the calculator, you don't make any mistakes. So this will be 0, 1. Inside the bracket, we have 3 multiplying 9,8. And then we have minus 25 multiplying the sine of 15. So then close the bracket and let's see what is this equals to. This gives us the frictional force of 2.29 if we round it off. I'm not sure if this is what you got on your side.
Yes, sir.
Okay, perfect. So this will be okay. So this will be Fk, it's equals to, we got 2,29 newtons. And this is a 4 mark question, okay? So when they give you mark allocation, when they do the mark allocation for this formula correctly, you'll get 1 mark, or they can mark this part here and give you a mark for that. And for understanding that, uh, this is the weight is this times that, and also for understanding this part, there's a 2 mark for that, and they'll give you mark for the final answer.
Okay.
All right. So now applying Newton's second law on each block to calculate the magnitude of the acceleration of the block. I'm not sure. Okay, we just want to try and work this down here. So on each block, so we need to first, let's start with the one that is, let's start with block A. We need to draw all the horizontal forces that are acting on block A. So this will be my block A, and I need to draw a free body diagram first. If your free body diagram is wrong, this affects everything. This will affect a lot of calculations. So on 2.3, I'm going to indicate all the forces that are acting here. There's a tensional force going in an opposite direction, and then there will be a frictional force, that is your Fk, and then there will be my Fx, which is the horizontal component. So are these the only forces? Yes, these are the only forces. There's only 3 forces on block A. Right. Then let me quickly draw my free body diagram here. We have tension going that side. We have frictional force, and then we have Fx. So Fx, that's the horizontal component. Remember, Fx is equals to F applied the cos of beta. Okay, right. Then when you have it like this is for block A. You need to choose direction for block A. Let's take the direction of the motion, which is left. So I'm going to take left as positive. Okay, so if I take left as positive, this leaves me with F bat is equals to MA, and then I'm creating an expression. Okay, so I'm creating an expression. So the forces that are going to the left, those are positive, then you subtract all the forces that are going to the right, and this is equals to MA. This is my expression. Remember, they said we need acceleration. So I'm going to do my substitution. I know that my Fx, that's Fa, the cos of theta, which is the F applied, that's 25. And then this will be the cos of theta applied at 15 degrees. Then I'm going to minus my tensional force. But I think let me first minus the kinetic friction, and which is what we calculated on the previous question. It was 2,29. Then you minus your tension, equate this. This is block A, which has a mass of 3. So this will be 3A. So now we're going to work out these two numbers and see what we get. Can you please quickly do that on your calculator? What is 25 the cos 15 minus 2.29? What is that equals to?
Okay, let me calculate that.
So this is uh, 75, the cos 15, and then
So
we
it's
minus
55 cos of 15 minus 2.29.
I got 21.86 if I round it off to two decimal place. Is that what you got on your side?
No, I have 24.0,
Oh, yes.
24.38.
Yes. That's correct. Wait, we said 25 that cost 15, right?
25 cos 15 minus 2.29.
You minus this two, what do you get?
21.86.
6.
Yes. So you know what I did, sir?
Mhm.
So you see when you put cos 15, I didn't close the bracket, I just put minus 2, so on.
Okay, and this gives us 21,86, and then
Yes.
we still have minus t, this is equals to 38. So I'm going to make tension subject of the formula. I can move it to the other side to be positive, bring the 3a this side to be negative. So this will be 21,86 minus 3a, it's equals to t. Let's call this equation 1. Then you're going to move to block that was block A. We're going to move to block B. So on block B, to create this kind of expression, you need a free body diagram for block B, meaning we need to indicate all the forces that are acting on block B. And there's only two forces, the weight going down and the tension going up. This is your tension. This is how the free body diagram will look like. So I'm going to say this is F net equals to MA, and we said the free body diagram looks like this. Tension up, FG going down. And then another thing that you need to pay attention on, we said we are taking left to S positive, and this, it accelerates like this. So if left S positive, we are forced to take up S positive for block B. So up S positive. So
Yes.
now, if it's up S positive, we take the tension, we minus the FG, this is equal to MA, and then this is the same as saying T minus MG, which is equal to MA. Then you do your substitution, tension minus the mass of 1.5, and then the gravitation, that's 9.8. This is equated to the mass of 1.5 A. Then we make tension subject of the formula. So we can definitely multiply this to, what do you get? What is 1.5 times 9.8?
1.5 times 9.8. 14.7.
14.7. It's equal to 1.5A. Let's make tension subject of the formula. Tension will be 1.5A. Then we add that 14.7. And this will be my equation 2. But remember, tension is equal, right? So I can equate both of these equations to find acceleration. I can say that equation 1 is equal to equation 2. So meaning that equation 1, that will be 21,86 minus 3A, and then equate this to 1,5A plus 14.7. Then let's solve for that acceleration. So this is the same as 21,86. Then you bring the 14 this side to be negative. On the other side, I have 1.5A. Then you add 3A, which is 4.5. 4.5A. Then you subtract the 2, 21.16. You're going to subtract that with 14.7. So 21 minus 14, that's 7. And 0,86, it's something. What do you get? It's 7 point what?
So I must add in the 21.86
Minus 14.7.
minus 14.7, which is 7.16.
7.16. Divide your answer by 4.5. What do you get when you divide by 4.5? What is the acceleration? 4 goes into 7 one time. What is the acceleration?
1.6.
1.2 two decimal place, it's 1.59
Yes.
meters per second squared. And that's the answer.
Okay.
Okay, so the next question says, the applied force is removed. We are removing the applied force. How? Okay, calculate the magnet. Oh, the applied force is removed. How will each of the following affect from choose, increase, decrease, or remain the same? If we remove the applied force, what will happen to the normal force? What is going to happen to the normal force if we remove the applied force? There's something that I need you to remember. This is the formula for normal force. Okay, so if this is the formula for normal force and we are removing the applied force, meaning that this part won't be available, all these components will be gone, meaning on the formula we cancel this, we're no longer subtracting anything. So the FG, we're no longer subtracting. We said the Fy was reducing Fg. Now the Fg is no longer reduced, the normal force increased. So the answer, the correct answer for normal force is increase. So the normal force will increase. Is that making sense? Johan, you still with me? You understand when we say the normal force will increase?
Sorry, sir, that it got cut off.
Okay, let me re-explain this. I was saying that if we remove the normal force, this is what
Yeah.
will happen, right? I mean, the applied force is removed. So if the applied force is removed, it means we are removing everything here. Do you understand? Even the horizontal and vertical components, everything is removed. So on the equation, we don't, for normal force, we don't longer have the Fy. So meaning the Fg is no longer reduced. It increased, meaning that if the Fg increased, also the normal force increased, because we're no longer subtracting anything from Fg. This tells you that the normal force will increase. Do you understand that answer for increase?
Yes, sir.
And how will this affect the coefficient of kinetic friction? Remember, the coefficient of kinetic friction always remain the same. It doesn't matter what you change, it always remain the same. That's the answer for coefficient of kinetic friction. It will always remain the same. Okay.
Okay.
Okay. The next question is, Helena throws a ball vertically upward, but fails to catch the ball on its way downwards. So the learner is going to throw a ball upward. So, but if you're throwing something, you're gonna start to throw it at a certain height. Do you understand? Because for sure this person is standing or something. Okay, let me read the question. The ball thrown to the ground and bounce few times if as it hits the ground. The velocity time graph describe the motion of the ball up to an unknown r. Okay, oh, it's fine. Take down as positive as the take downwards as the negative direction. Okay, so we are taking down as the negative direction. Okay, it's fine. Let's answer some of the questions. What was the velocity of the ball thrown upward? Do you know where all this thing starts?
Is the starting point R?
Nope. It's going to start here.
Yes.
This is
Oh,
where it
yes, because
starts.
it bounces down, up. Yes.
So it starts at 6 meters per second. This is the initial velocity. So this is V initial. Calculate the time indicated by point P. Look at this point P. What is the velocity at point P? It's 0, right?
0.
So you see all this point, all this point, all those point. Uh, this is where the velocity is at its max. It's at max height. It's at max. That's why the velocity is 0. It's at max. That's why the velocity is 0. Meaning that if a person throws a ball upward like this, it starts from a certain height, and then the person will throw it up, then it reaches the maximum height, then it will travel down the ground. That's when it start bouncing. The more it bounces, the more it decreases the maximum height. You understand? So these are your max n, and the one that we are looking for is this one, the first max. That's P. You just have to understand this direction, this path here. Now, at this point, the V initial is 6 meters per second. And at this point, the final velocity is 0 because it's at max. That's the final velocity. If you understand that part, everything is easy. So you're going to say you have data. We know that it starts with the V initial of 6 meters per second, and then the V final of 0 meters per second at point P. So we are looking for delta T. So we need to choose the formula that has this 3, which is V final is equals to V initial A delta T. So they said we need to take down as a negative direction, meaning up as positive. So all the forces that are, all the motions that are going up will be positive. Final velocity is 0. Initial, that's 6. So it has a 6 plus the acceleration which goes down, it will be negative 9.8. And we are looking for the time at point P, the time at point P, delta T. So I'm going to bring the 6 this side to be negative 6. and then this is negative 9.8 delta t. You can definitely divide both sides by that 9.8 and then divide the other side by negative 9.8. So whatever that you get, it's your t at p. What is minus 6 divided by negative 9.8? What do you get?
9.6 minus negative.
We are not subtracting, we are dividing. Minus 6 divided by negative 9.8. Because
Oh, okay.
these two cancels, then on the other side it's minus 6 over minus 9.8.
8. I've got 0.61.
So 0.61 seconds. This is the time at point P. So the time here is 0.61 seconds. Are you happy with that?
Yes, sir.
Okay, next question. Calculate the magnitude of the velocity indicated by point Q on the graph. Magnitude of the velocity. I don't see Q. Where's Q? Oh, there
Is
it
at the
is.
bottom.
This is Q. So
Yes.
you see this point here. Okay. This point here, I want to help you understand how to analyze this graph. You need, in order for you to analyze the graph, you need to understand what is going on here. Okay, so when they say calculate the magnitude of the velocity indicated by point Q on the graph, point Q is the final velocity where it hits the ground. So this is where it's going to hit the ground at that point, and also this point is where it's going to hit the ground. Understand? So the more it bounces, the more it decreases in velocity. It's fine. Okay, so now let's find that path. So to find that path, already we have some information about this. So we are looking for this path now. Okay. All right. So I need you to pay attention on what I'm going to do now. Okay? So you know what I'm going to do. I'm going to say that if the ball, how can I say this? It hits the ground at this time. So delta t at this point, it's 1.40. Can you see that part? So this
Yes.
is 3.2. Then up here, I'm going to put my 3.3. Okay, so if I do the data, I have my V final, which is what you are looking for. We have V initial, which is 6, and then we have acceleration, which is negative 9.8, and then the time, it's 1.4. So we are looking for what? We are looking for the final velocities at point Q. You just use that time. You just have to say your V initial, or V final is equal to V initial plus A delta T. That's how easy the question is. You substitute 6 plus into negative 9.8. The time is 1.4. Then you substitute that on the calculator to find your final velocity. So remember, we set it down as positive. The answer should be negative. The answer should be negative. What is your final velocity? You need to punch that on the calculator. What do you get as your final velocity?
So it's the 6th class.
Into negative 9.8 times 1.4.
8 times 1.4. I get negative 7.72, sir.
Negative 7.72 meters per second. But you can say V final is equal to 7.72 meters per second. Do you understand?
Yes, sir.
Okay, now the next question says 3.4. Without using equation of motion, calculate the height from the ball from the ball is thrown without using equation of motions. If they don't want us to use the equation of motions, we need to find, we are looking for the height. Let's go. They said calculate the height from which the ball is thrown. The height from which the ball is thrown. Okay, look at this. This, it was thrown here at that height. It reached its maximum point, this part, and then it reached the ground here. So we are looking for this height here. It traveled with that path, and also the height it traveled with this path. Do you understand? We add the
Yes.
two, or you can find okay, so I'm not sure if you can see these two triangles. Can you see these two triangles? This one,
Yes.
that triangle. Can you also see this triangle?
Yes.
So to find the height, you can take, you can find the area under the graph. So we can find the area of this part of that triangle. We add it with the area of that triangle. We can find the two areas and add them together. You understand?
Yes.
Yeah, I think it's going to be best if we do it like that, but it might also be challenging. But let's find that. So we can add the two areas. So we're going to say the height is equals to the area under the graph. But we have two triangles now. So we're going to add two of them. I'm not sure if you want me to name them. P, let's call this maybe MOS. So it's going to be the area of OSP OSP plus the area of OQ. It's going to be POX, PMX. I'm just doing my points here. I'm just going to find the area of OS. It's half, since it's a right angle triangle, it's half base times the height. And then the other one will also be half base times the height. So let's start with OSP. What is the base? The base will be the distance from this point here. Let me indicate that with a different marker. The base of the first triangle is this one. So it's going to be 0.61 seconds. So it's 0.61. So the base will be, for this one, that 1 over 2, 0.61. And then the height of the first triangle is from this point to that point, which gives us 6. So this will be times 6. So this will be 6 plus, let's go to the second triangle. They said we don't have to use equation of motions. That's why I'm doing this. The base on the second triangle will be the distance from this point here to that point. That's the base. But look at this. It's 1.40 minus the 0.61. You need to take 1.40, then you minus 0.61. Can you try minus that? Tell me what you get.
Okay.
Because remember, 1.4 is from this point all the way to that point. That's 1.4. So to find the distance of that green part, we need to say 1.40, you minus 0.61. What is that equals to? Is it giving you a lot of numbers?
So 1.40 minus 6.9.
1.40 minus 0.61.
Oh, 61. I get negative 47 over 10.
Is that possible to say 1.4 minus 0.61, then you get your answers negative? That's not possible.
Yeah, I put 1 comma 40
Mm-hmm.
minus 6 comma 1.
No, not 6. 0.61. Do you
Um,
understand why? What are we subtracting here?
yes, sir.
Look at this. We have something like this, right? At this point, this is 0.61. This is 0. This is 1.40. So we know that the distance from this point to that point, it's what? 1.40. And we only need this part. So to find that part, we need to subtract this part here. We subtract that part from 1.40. So that's why we are saying 1.40, you subtract 0.61. Then the answer that you get, it will be
I got 0.79.
perfect. So this will be 1 over 2 will be the base of 0.79. And then what about the height? Let's go find the height. The height, it should be this part here, which is what? We calculated that on the previous question, it was negative 7.7. Please make sure that you also include the signs when you calculate. It's negative 7.72. So you're going to put it inside the bracket as negative 7.72. So this will be negative 7.72. The reason this 6 is positive is because it's going up. So now you're going to put all this on the calculator and find your final answer. Let's quickly do that.
Okay. So it's 1 over 2. And then do I put times or just open brackets?
Even if you just put open bracket, it's fine.
Okay. Mm,
Then when it gives you an error, that's when you can consider putting a
Okay.
time. I get negative 1,2194. If I round it off to two decimal, it's negative 1,22, which is positive 1,22.
Yes, I have the same thing, sir.
So the height, it's negative 1,22 meter, which is height, it's equals to 1,22 meter. So it was thrown at 1,22 meter. Do you understand?
Yes.
Okay. So the next question is asking to calculate R. Calculate the time R shown on the graph. To find the time R, this is your R, né? This is your R. And this looks like it's going to be very, very like challenging to find that part. Okay, so now I think we need to work out on something, because if now I'm considering remember at R is the mark, it's at max, né? So I need to first start here. I have the initial velocity as 5, but it's going down, so that will be minus 5. You see, it's going down. Am I? No, it won't be minus 5. I'm sorry. It won't be minus 5. But you see this point here. You see this path here. You see that path. Hmm?
Yes.
Right. Is this portion here? Let me indicate that with a different marker. It's this portion here. Right. So let's say this is maybe M. Let's say maybe this is O. So now at this point here, this is your max. Let's call it maybe K. So this is M, then this is K, this is O. I need you to understand that the velocity that it moves, the velocity that it bounds the ground on is the same velocity that it will come back on the ground with. So the velocity here, the V initial here, it's 5. The V final that it will come back with, it's also 5. So we can use this information to calculate the time at this point. Because if we can find this time, it comes back on the ground. The time that it hits the ground with, then we are good to go. So I'm going to use this information. But if you look at this, for V final, it's going in a downward motion because this is the part where it's going down. So this tells you that the velocity will be negative. So I'll definitely work around that. Let me write this down first. For 3.5, we said V final is equal to V initial plus A delta T. And then my V final, we said it's minus 5. And then my V initial, that's 5, which 5 plus the acceleration of negative 9.8 delta T. So the 5 comes this side to be negative. This gives us minus 10 is equal to negative 9.8 delta T. When you divide both sides by minus 9.8, divide minus 10 by minus 9.8, what is that equals to?
Um, 1,02.
The time is 1,02 seconds. So this 1,02 seconds is the time that it's gonna hit at that point. So at that point, delta T, it's 1,02. So now, if it hits, oh, I'm sorry. The 1,2, it's here. Okay, it's fine. It's fine. It's fine. I'm coming back to that part. That's 1, which part is this? This is wrong. This is the time at this part, it's 1,02. So now what I'm going to know, I know that at this point here, at that point, at this point, what is it? At this point, we know that the time is 1,02. So now I'm going to, I know that the final velocity here, V final, this is not V final, but my V initial. My V initial, we said that is gonna be, it's given as 3. So my V initial there is 3. And then my V final here is 0. V final, it's 0. Then let's use this information to calculate the time at R. Then you'll see what I'm going to do finally. So I'm gonna use the same formula. V final, it's equals to V, let's maybe find something strong. V final is equals to V initial plus A delta T. My final velocity, it's 0 at R. My initial is 3, which is positive. Né? So this will be 3 plus negative 9,8, then delta T, which is what you are looking for. Bring the 3 this side to be negative. So this will be minus 3. Minus 3, it's equals to negative 9,8 delta T. Therefore, divide both sides by minus 9.8. So delta T is equals to 3 divided by 9.8. And this gives us 0,31 seconds. Okay, so if this is 0,31, this is the time that it will take to get to this part. So to find R, you're going to take this point here, 1.4, then you add your 1,0, then you add your 0.31. Then we'll know what is R. You add all those times. You add all those times. So this will be, the final answer will be T is 1.4. We add that with 1.02. We add with 0.31. Then the answer that you get is your time. So let's quickly add those ones. 1.4 plus 1.02. So this gives us 2.73 seconds. That's your time. So if you work with this step by step, you'll understand why we are adding all these times. Why we are adding all these times, because adding all these times will give us R.
Okay.
Is that, are you happy with that one?
Yes, sir.
Okay, I did revise, I think I did revise, what is this? I did revise equations, no, momentum, we did do that. And then we did work on electrostatics. We did work on electrostatics. And the questions that I haven't covered with you, I think it's circuits. We haven't done circuits, right?
Yeah.
I haven't done circuits with you. So, okay, let's quickly look at these questions. Just gonna try and answer these questions, or tell me. So now what you're going to do, it says that, but I'll also send you the video where I'm working on circuits, okay?
Okay, no problem.
So they say that the circuit diagram below shows two light bulbs connected in parallel to a battery with an EMF of 3 volts. And they say that an internal resistor of 0.1, the battery is connected to two switches S1 and S2. Which are also parallel, as well as two bulbs R1 and R2 in parallel. A third switch S3. So they just tell us what we see. I'm just going to skip that part. State Ohm's law in weight. Ohm's law in weight. Okay, so when we state Ohm's law in weight, we say that the potential difference across the potential difference across a conductor is directly proportional. It's directly proportional to the current in the conductor at a constant temperature. Okay, now with switch S1 and S3 closed, calculate the total resistance of the circuit, the total resistance. So we are closing S1 and S2, and they want us to find the total resistance of the circuit. If we're looking for the total resistance, how many resistors do we have? There's R1 and R2 only. There's only two which are connected in parallel. How do you know that resistors are connected in parallel? This is what you do. Let's say maybe the current moves through this part. Can you see that the moment it gets earth injection, it will split in that way. So the moment you see a current splitting, even when we come this side, you see that's a injection. You can consider and say R1 and R2 are connected in parallel. So to find the total resistance for parallel, that's 8.2. This is what you do. 1 over RP parallel is equals to 1 over the first resistor plus 1 over the second resistor. Then that's when you can do your substitution. 1 over the first one is 2. You add with the second one, which is 4. So on your calculator, tell me, what is 1 over 2 plus 1 over 4? What do you get when you add those two fractions? Johan,
Yes.
what is 1 over 2 plus 1 over 4?
Calculating it. I get 0.75, so.
I need it in fraction.
Oh, 3.3 over 4.
I'll explain why.
Okay.
Leave it in fraction because look at this. We are looking for the RP,
Yes.
not 1 over RP. Then that's when you can cross multiply. Say RP times 3, that's 3 RP, which is equals to 4. 1 times 4 is 4. Therefore, you divide both sides by 3. So your RP is just 4 over 3, but you don't have to go all that trouble. When you get to this step, you can just say your RP is the reciprocal of that fraction. That's why I need it as a fraction. So your RP will be, you interchange the denominator and the numerator, and then that's when you can punch your calculator and say your RP is 1,33 ohms. Do you understand how I did that question?
Yes, sir.
Okay. The next one, they say, calculate the current that passed through ammeter A1. Okay, so A1 will read a total current. Just know that A1 will read a total current. So the current that passed through this part and that part is a total current. And we're going to use Ohm's law and say for 8.3, the Ohm's law says that the R total is equals to the voltage, but we need to use the EMF voltage, né? Divide by your I, which is what we are looking for. So the RP is what we just calculated. So no, it's not what we calculated, the total current, meaning that we need to I'm sorry, the total resistance. We need to first find our R total. So the R total, it will be the internal one we add with the R parallel. The R parallel was 1,33. We need to add that with 0,1. So what do you get when you add these two? 1,33. We're going to add 0,1.
I get 1.43. Or do you want the other form?
Yeah, 1,43 is fine. I'll take the decimal, it's fine. 1,43. So this is 1,43. Let's go and substitute it then. Eh? So my RT is 1,43. This is equal to VEMF, that's 3. So this will be 3 over the current. Let's make I subject of the formula. I'm going to cross multiply. This is over 1. Then the 1,43 multiplied by the current, it's equal to 3. Divide both sides by 1,43 to find the current as 3 over 1,43. Whatever that you get, it's your current. So what is 1,43? 3 divided by 1,43.
Yeah, 3 over 1.43.
You got?
I've got 2.09.
If we round it off, that's 2.10 amperes, right?
Yes.
Okay, so now there is another way that we can solve this problem. I think this is the way that I'll prefer us to do the formula. Remember, the formula for EMF is the current inside the bracket, R plus the R internal. Then we just substitute. The EMF is 3. The current is what we are looking for. We find the RP, the total, the external. So this is like saying, let me rewrite this equation correctly in a way that we're gonna understand it. Né? So EMF is equal to the current into your R external plus your R internal. So This is 3. Your R external is 1,33, what we calculated. Your internal is 0,1. Then this is 3, it's equal to the current. This was 1,43. Divide both sides by 1,43. Divide by 1,43. Tell me, which method do you prefer?
I prefer the first one, but both is a simple stuff.
Okay, perfect. Right. Calculate the reading on V. The reading on V. So when they say the reading on V, this is the reading that they're looking for, the total voltage. And we can use Ohm's law for that. I think this one is an easy question. 8.4. V is equals to the current times the resistor. So we're going to use the total current, which was 2.01, which is the one that we just got. And then you're going to use the external resistor, which was 1,33. The external, this is R external. You use the R external. Then when you punch that on the calculator, it should give you the answer. What is that equals to?
I have 2.80.
Did you round it off correctly? Because if I take
Because, okay, so on the calculator, I got 2.79.
2.10 times 1,33, 2.79.
79. Yeah. So it'll be 2.80.
No, 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 no. We round it off to 2 decimal places, so it's just 79.
Okay.
We change the 9. The deciding digit is 3. So 3 is the one that says we don't have to change the 9. We leave the 9 like that if we're rounding off to 2. But if you're rounding off to 1, that's when it's going to be 2.8 only.
Okay.
So this will be 2,79 volts. Right. Explain what happens to the reading on A2 if switch S2 is also closed. So switch S2 is closed. What will happen to A2? So remember, if we are closing this one, what will happen to A2? So if you look at this now, we have two paths where the current can flow. It's either that current will flow in that direction. Now, if we close this part, other current will move in that direction. So can you see that this will reduce the current that will pass on A2? Closing this part means other current will flow this side. So this has two paths where the current can flow. So if we close this one, other current will move from A2 to that other side. Then that's when they will meet at that point again. So this tells you that closing switch has to reduce the current on A2. So this will decrease. Okay, so they said, explain what happens. So this means that we're going to say it is reduced. So the current is decreased, is decreasing, or you can say it's reduced. Calculate the power dissipated in resistor R2. So when they want us to find the power dissipated in resistor R2, that will be for R2, you just have to know the information. So for R2, we have resistor S4, and then this will read the voltage. Let me write the information. This will read the voltage of 2.79, what we just calculated. So for 8.6, the R is 4, and then the voltage is 2.79, and we are looking for P. You go to your formula sheet, you look for the formula that has RVP. So the formula that has RVP is P is equal to V squared over R. Then you just substitute. Your V is 2.79, everything squared. Your R is 4. So whatever that you get is your power, and it should be in watts.
So I got two That's 79, sir.
Yes,
2.79
yes, 2.79 squared.
squared over 4. I have 1.94.
1.94. If you round it off, what is that equals?
1.96.
1.94 to 1.96.
1.95, my bad.
1.95.
Yes.
And that's it. So that was the last question. I think circuits, most of the circuit questions are very easy. Eh?
Yes.
Yeah, I think I still we just did an hour. I think I still owe you that 15 minutes. We'll cover it on maths or paper too. Ne?
No problem.
Yeah, and all the best for tomorrow. Ne?
Okay, thank you, sir.
Okay, sharp, sharp. I'll see you during the
Um,
weekend.
so could you just send me the notes as well?
Okay, I'll send them now.
Okay, thank you.